Good day, everyone. Now we are going to solve different problems on higher order differential equation. First problem is to construct linear combination of functions suitable for finding a particular integral of the given differential equation using a method of undetermined coefficients. Here is our differential equation: y triple prime minus 6y double prime plus 12y prime minus 8y is equal to x squared e raised to 3x minus 7x e raised to 2x. We first solve the associated homogeneous equation. The equation is y triple prime minus 6y double prime plus 12y prime minus 8y is equal to 0. We try to find the solution of the form y is equal to e raised to mx. We are going to solve its first derivative, second derivative, and third derivative. We substitute this into the homogeneous equation, and this will result to m cubed e raised to mx minus 6m squared e raised to mx plus 12m e raised to mx minus 8e raised to mx is equal to 0. Then after this, it will result to e raised to mx times the quantity of m cubed minus 6m squared plus 12m minus 8 is equal to 0. E raised to mx is not equal to 0 for all x. It is apparent that the only way y is equal to e raised to mx can satisfy the differential equation is when m is chosen as the roots of quadratic equation. The auxiliary equation is m cubed minus 6m squared plus 12m minus 8 is equal to 0. And the roots are m1 is equal to 2, m2 is equal to 2, and m3 is equal to 2. We have repeated real roots, so our complementary function is yc is equal to c1 e raised to 2x plus c2 x e raised to 2x plus c3 x squared e raised to 2x. To find the particular solution yp, we correspond that x squared is equal to x squared e raised to 3x will be ax squared plus bx plus c times e raised to 3x. And we assume that 7x e raised to 2x is dx raised to 4 times e raised to 2x. Our particular solution is yp is equal to ax squared e raised to 3x plus bx e raised to 3x plus c e raised to 3x plus dx raised to 4 times e raised to 2x. We are going to find its first derivative, second derivative, and third derivative. And these derivatives, we will substitute this to the equation y triple prime minus 6y double prime plus 12y prime minus 8y is equal to 0. And so we will have this equation, this. After that, we will group like terms, and we obtain this four equations: 27a minus 54a plus 36a minus 8a is equal to 1, and the second equation is this, and the third equation is this, and the fourth equation is this. Solving for a, b, c, and d, we have a is equal to 1, b is equal to negative 6, and c is equal to 12, and d is equal to negative 7 over 24. Now we have our particular solution. The particular solution is yp is equal to x squared e raised to 3x minus 6x e raised to 3x plus 12 e raised to 3x minus 7 over 24 x e raised to 2x. Now we have our general solution, which is y is equal to yz plus yp. Now this is the general solution of this equation. Y is equal to C1 times e raised to 2x plus C2x e raised to 2x plus C3 x squared e raised to 2x plus x squared e raised to 3x minus 6x e raised to 3x plus 12 e raised to 3x minus 7 over 24 x raised x times e raised to 2x. Now, next problem is, using the method of variation of parameters, find a particular integral of the equation y double prime plus y is equal to x raised to 1 half. From the auxiliary equation, we have m squared plus 1 is equal to 0, and we will have m squared is equal to negative 1, which is equal to m is equal to I. Now we have the complementary equation, which is yc is equal to c1 cos x plus c2 sin x. With the identifications y1 is equal to cos x and y2 is equal to sin x, we next compute the Wronskian, which is the Wronskian of cos x and sin x is equal to cosine squared x plus sine squared x is equal to 1. We identify the function of x, which is x raised to 1 half. We now solve for w1. Our w1 is equal to negative x raised to 1 half sine x, and our w2 is equal to x raised to 1 half cos x. We now solve for its u1 prime, which is equal to w1 and our w, which is equal to negative x raised to 1 half sine x over 1, and it is equal to negative x raised to 1 half sine x. We now find its integral, which is equal to t raised to 1 half sine t dt from the values of x sub 0 and 2x. And our u2 prime is equal to w2 divided by w. Our w2 is equal to x raised to 1 half cos x. Now we integrate this function. We have t raised to 1 half cos t dt from x sub 0 is 2x. Now we have the particular. Since the foregoing integrals are non-elementary, we are forced to write that yp is equal to u1 y1 plus u2 y2 is equal to negative cosine x plus t raised to 1 half sine t dt plus sine x times the integral of t raised to 1 half cosine t dt. And so the general solution is y is equal to c1 cosine x plus c2 sine x minus cos x times the integral of t raised to 1 half sine t dt plus sine x times the integral of t raised to 1 half cosine t dt. Next problem is we are asked to find displacement y is a function of time given that w is equal to 45 kilograms, k is equal to 9 kilogram per centimeter, y sub 0 is equal to 0, and v sub 0 is equal to 28 centimeter per seconds. Assuming that there are no retarding force acting on the system and assuming that the mass vibrates free of other external forces, we can equate Newton's second law with net or resulting force of the resisting force and the weight. And this equation will be equal to m d squared y over dt squared is equal to negative k times s plus y plus mg. And this will result to negative ky plus mg minus ks. And this equation will become 0. And we are left with m, the second derivative of x with respect to t is equal to negative ky. So we must first convert the units of weight given into units of mass. From m is equal to w over g, we have that w is equal to 45 kilograms and g is equal to 80 centimeter per second squared, and we have 9 over 196 kilogram per centimeter per second squared. Now we have this equation. 9 over 196 plus d squared y plus dt squared plus 9y is equal to 0. Dividing by the mass m, we obtain the second order differential equation, which is the second derivative of y with respect to t plus 196y is equal to 0. We now find a particular solution which we will let y is equal to e raised to mx and y prime is equal to m e raised to mx and the y double prime is equal to m squared e raised to mx. We now substitute this equation to this equation. So we have now m squared e raised to mx plus 196 e raised to mx is equal to 0. And there are no solutions of e raised to mx is equal to 0. So we take this m squared plus 196. So we can have our roots, which is equal to m is equal to 14i. Now our general solution, y of t is equal to c1 cosine 14t plus c2 sine 14t. Now we have that y sub 0 is equal to 0. Now we substitute this, so this y of 0 is equal to 0. In this equation, we will have 0 is equal to c1 cosine 0 plus c2 sine 0, and we will have an answer of c1 is equal to 0. So we will have now the equation y of t is equal to c1 plus c2 sine 14t. Applying v sub 0 is equal to 28 centimeter per second to y prime of t. So we have our y prime of t is equal to 14c2 cosine 14t. And the derivative of as t is equal to 0 is equal to 28 equal to 14c2. And we will solve for c2, which is equal to 2. Now we have our equation of motion, which is y of t is equal to 2 sine 14t.